Every second, your computer is running dozens of tasks at the same time. But here's the thing, there's only one CPU to handle them all. So, how does it decide which task runs first and for how long? That is where CPU scheduling comes in. It is the process of managing the order and timing in which the different processes access the CPU. Let's start with the simplest CPU scheduling algorithm, FCFS. Just like the name says, the process that arrives first gets the CPU first. It works just like a queue at a ticket counter. Whoever comes first is served first. In FCFS, once a process starts running, it runs until it finishes. No interruptions, no preemption. This makes it easy to understand and implement, but it also has a big drawback. If a long process comes first, it can delay all the smaller ones behind it. For example, we have three processes P1, P2, and P3. P1 arrives first and needs 10 units of time. P2 needs 4 and P3 needs 2. But since P1 came first, it runs first. P2 and P3 will wait for P1 to finish before they can start. The CPU will execute them in the exact order that they arrive P1, P2, and finally P3. This creates a simple and clear execution order. Every process gets its turn based purely on when it arrived, making it very easy to organize. FCFS is often the starting point when learning CPU scheduling because it lays the foundation of understanding how processes are lined up and managed by the CPU. It is straightforward, structured, and works best when tasks are lined up in a simple, orderly manner. Now let's look at another popular CPU scheduling algorithm, shortest job first or SJF. As the name suggests, the process with the shortest burst time or execution time gets the CPU first. This means that among all the processes waiting, the one that will take the least amount of time to finish is chosen to run next. It's like letting the quickest task go first so that things move faster overall. For example, imagine four processes P1, P2, P3, and P4. Their burst times are P1 is equal to 8 units, P2 is equal to 4 units, P3 is equal to 2, and P4 is equal to 6. Here, the CPU will start with P3 because it needs only 2 units of time, and then P2 with 4 units, followed by P4, and finally P1. This ensures that the shortest jobs are completed first, making the average waiting time for processes shorter. SJF can be applied in two ways non preemptive, where once the process starts, it runs till completion, or preemptive, also known as shortest remaining time first, where a shorter new process can interrupt the current one. It is a smart and efficient way to schedule tasks. Let's talk about priority scheduling, one of the key CPU scheduling techniques used in operating systems. Now, imagine a real life scenario. There's a young man, an older woman, and an older man standing in line at a clinic. Even though the young man arrived first, the clinic gives priority to senior citizens. So the older woman is attended to first, followed by the older man, and then the young man. Similarly, in priority scheduling, processes are executed based on their priority levels. Higher priority processes get the CPU first, and lower priority ones wait for their turn. Let's talk about round robin scheduling, one of the most fair and widely used CPU scheduling techniques, especially in time sharing systems. In earlier methods like FCFS or priority scheduling, a single process could hold the CPU for a long time while the others waited. But round robin solves this by dividing CPU into small time quantum units. Each process gets the CPU for a fixed time, and if it's not finished, it goes back to the queue to wait for its next turn. Now imagine this like a line at a fast food counter. There's a young man, an elder woman, and an older man waiting for their orders. Instead of serving one person completely before moving on, the server gives them a short turn, like taking their part of the order, then moving to the next. After the last person, the server returns to the first, and the cycle continues. This ensures that everyone gets attention in a fair and predictable manner. No one is left starving for service. Round robin is especially useful when multiple processes arrive around the time and need quick responses. However, choosing the right time quantum is crucial. Too short can lead to too much context switching, and too long can make it behave like FCFS. In short, round robin is all about fairness and responsiveness, giving each process an equal chance to execute and keeping the system interactive and balanced. Now we look at round robin calculation, where we make a table which includes the arrival time, the burst time, and the completion time. According to this table, we calculate the amount of time that is given to each of the processes in order to conclude a round robin problem. Let's talk about multi-level queue and multi-level feedback queue scheduling. In multi-level queue scheduling, processes are divided into different queues based on priority or type, like system or background tasks. In multi-level feedback queue, they allow the processes to move between queues, giving short tasks quick access and handling longer ones more efficiently. However, scheduling can face issues like starvation and overhead. To fix this, aging and proper time management are used. Thank you for watching and learning with us.